Okay, so starting off this new section, we're going to be looking at trigonometric functions. So as a quick reminder, trigonometry is triangle measurement, okay? Trigonometry is used in astronomy, navigation, architecture, pretty much anything with triangles, you've got trigonometry in it. And a couple things. So we're looking at trig functions specifically. So the input of trig functions are going to be angles. Okay, these can be angles from 0 to 180, like you saw in geometry, as well as angles less than 0, so that would be negative, and greater than 180, so that's, 200, 400, and so on. The output you get from trig functions is a number value. So you're going to take an angle and you're going to get a number back. Okay, and those can be negative or positive numbers. They don't have to be solely positive. Now, for trig functions have direction. So positive angles go counterclockwise in rotation. Okay, so for an example, if you look to the right a little bit, let's look at the angle 225. Okay, so all of our angles we can place on a coordinate axis. Coordinate axes always start on the positive, our angles will always start on the positive x-axis. So that would be right here. That's going to be considered angle 0. Okay, so 0 degrees is that x-axis. Now notice, my drawing is not very exact, but this angle right here between the positive x-axis and the positive y-axis is 90 degrees. So the angle value of the positive y-axis is 90 degrees. And then you move another 90, right, to the negative x-axis, so that's 180. And then you move another 90 to the negative y-axis, so that's 270. And then you move back to 0, and that's 360 degrees. Okay, so it makes a circle, and circles have degrees 360. Okay, so for 225, we want to find where 225 is. So since we're moving in the positive direction, we're going to move, our arrow's going to move in that direction, and we're going to go to 225, which is greater than 180 but less than 270, so we're going to be right there. So this is the angle 225. Okay, this first side starting at 0 is the initial side of our angle. This end side where the arrow ends for our angle, this is going to be our terminal side. Okay, and this drawing itself is the standard position of an angle. Okay, so whenever it asks you to draw in standard position, you do that. Now, the last thing I want to mention are quadrants. Notice that our coordinate axis breaks up into 4 separate zones. And since positive direction is counterclockwise, quadrants are named in the counterclockwise fashion. So the first one from 0 to 90 is quadrant 1. The second one from 90 to 180 is quadrant 2. The third one from 180 to 270 is quadrant 3. And the fourth one from 270 to 360 is quadrant 4. Okay? The second type of directed angle is our negative angles, okay? And those move in the clockwise direction. So let's look at negative 60. We always start again at 0, and 0 is always a positive x-axis. So our initial side will still be the positive x-axis. But instead of moving in the positive direction, we're going to move in the negative direction. Okay, but our angle values are still the same. So now we're going to go 0 degrees. We move 90, so that's negative 90 degrees. Move another 90, so that's negative 180. Move another 90, that's a negative 270. Move the last 90, negative 360. Okay, now negative 60 is in between 0 and negative 90, right? So we're going to stay in our quadrant 4 right there. This is negative 60 degrees. Okay, this is our terminal side right there. And this is the standard position of the angle. Now, just because we move in the negative direction does not mean that our quadrants change numbers. This quadrant that we're in currently is still quadrant 4. Okay, so all the quadrant names stay the same. We're just moving in a different direction. Okay, it's like if you took what's a good example? If you took, a revolving, like if you were just revolving some sort of circular object, just because you are moving in the negative direction, so instead of swinging it to the right, you're going to swing it to the left, you still end up covering the same distance, right? It's just now you're moving in the different direction. It doesn't necessarily mean that the places you're going through are different. It's just the way you're going through it is different, if that makes sense. So now that we've done a whole bunch of essentially just talking about trigonometry in general and some basic ideas of trig, we have to then focus on trigonometric functions. There are 6 in total, and the first 3 are given to us through SOHCAHTOA. Okay, so hopefully most of you remember SOHCAHTOA from geometry as well as maybe even Algebra 1. All right, and so SOHCAHTOA, the first 3 letters tell us that sine, which is one of our trig values, trig functions of theta being an angle, is equal to opposite over hypotenuse of a right triangle. And if you look to the right of my screen, I have a right triangle drawn for you so you can see what it looks like. Okay. We abbreviate sine usually as sin of theta equals opposite over hypotenuse. Now, because we're going to be dealing in the xy plane a lot, I have drawn a separate, if you notice, I have said that adjacent is equal to x, opposite is equal to y, because it's adjacent's on the x value, opposite's on the vertical side, and then hypotenuse is equal to r. So using those new letters, we can say that sine must also then be equal to y over r. Then we've got the next 3 letters, CAH, tell us that cosine, or COS, of theta is equal to adjacent over hypotenuse. Okay, adjacent is equal to the x value, and hypotenuse is still r. Then lastly, tangent of theta is equal to opposite over adjacent by SOHCAHTOA. So then this is the same thing as y over x, or sine theta over cosine theta. Okay? And so then the next 3 trig function values are derived from these first 3. So for example, the next one, cosecant theta, it's quite common to think that cosecant goes with cosine, but actually it goes with sine. And cosecant theta is the reciprocal of sine theta. So this is 1 over opposite over hypotenuse, which is equal to hypotenuse over opposite. So another way to write this in terms of our xy coordinates, r over y. Secant theta is the reciprocal of cosine theta. So this is 1 over adjacent over hypotenuse. So this is hypotenuse over adjacent, or r over x. And then lastly, cotangent is 1 over tangent theta. So this is 1 over opposite over adjacent. So this is adjacent over opposite, also written as x over y, or even cosine theta over sine theta. Okay? So those 6 trig function values, you have to find a way to memorize them. If you can remember SOHCAHTOA and then know that the rest are reciprocals, you should be golden. So let's look at some examples. The first example we're going to look at is on the left of the screen. Okay, they give us this right triangle with acute angle theta, okay, where the opposite side is 5, the adjacent side is 12, and they want us to find the 6 trig function values. The only problem is, if you notice in the last slide, we had a value for our hypotenuse. As of right now, we don't, okay? But the nice thing is that we have a right triangle, so we can use Pythagoreans to find our hypotenuse. So we're going to do 5 squared plus 12 squared is equal to r squared. So 25 plus 144 is equal to r squared. 169 is equal to r squared. R is 13. So we put a 13 there. And so now we're going to find all of our trig function values. So sine of theta is by definition opposite over hypotenuse. Our opposite side from our angle is 5. Our hypotenuse is 13. Cosine is adjacent over hypotenuse. So this is going to be 12 over 13. And tangent is opposite over adjacent. So this is going to be 5/12. Okay, to find the remaining trig function values, we're just going to do the reciprocal of each. So cosecant is the reciprocal of sine. So this is going to be 13 over 5. Secant is the reciprocal of cosine. So this is going to be 13 over 12. And cotangent for some reason my pen doesn't want to write tonight. Cotangent is the reciprocal of tangent. So this is 12/5. Okay, let's look at another example. For 8, they give us the point 5, 5, okay? And what I did is I then plotted that point 5, 5 right there, okay? I drew a connecting segment from the origin to that point, and then I labeled the distance from the positive x-axis, or 0 degrees, to that segment as theta, okay? And then I drew a right triangle from that point. So since the point is 5, 5, that means we move horizontally 5 and vertically 5. So our adjacent side is 5 and our opposite side is 5. We, again, are missing our hypotenuse. So we're going to do Pythagoreans to find that missing hypotenuse. So we get 25 plus 25 is equal to r squared. 50 is equal to r squared. R is equal to 5√2. Like so. Okay, and now that we have all the sides of our triangle, we can find our trig function values. So sine theta, again, is opposite over hypotenuse, so that's 5 over 5√2. You cannot leave this root 2 in the denominator, though, so you need to rationalize it up. So you get 5√2 over 10, which is √2 over 2. Cosine theta is going to be adjacent over hypotenuse, so that's 5 over 5√2. Again, we have to rationalize that √2 out, so we end up with √2 over 2. Tangent theta is opposite over adjacent, which is 5 over 5, so this is just 1. Cosecant theta is the reciprocal of sine theta, so that's 2 over √2. Rationalize that √2 up, so we end up with √2. Secant theta is also the reciprocal of cosine. So this is going to be 2 over √2. Rationalize that √2 up, you end up with √2. And cotangent theta is adjacent over hypotenuse. So this is 5 over 5, which is 1. Okay. Now let's look at 12.3. In 12.2, we were looking at trigonometric functions of acute angles. So that means all of our angles were small, less than 90. Yes, so we were always in quadrant 1. In 12.3, we're looking at trig functions of general angles. So that's any angle. So that can be, 340. That can be -20. Anything goes here, okay? So what we first have to define then is what's called a reference angle. Okay. Reference angles are unique acute angles, so that's less than 90 degrees, formed by the terminal side of theta and the closest x-axis. You never have a reference angle in terms of the y-axis, ever. Never, ever, ever, okay? So let's look at an example where we're asked to find the reference angle. So theta is 300, so I'm going to draw that in standard position. So it starts at 0 and then moves 300 degrees. So that means you end up in quadrant 4. Okay, this is theta. My acute angle is formed between my terminal side, that would be right here, and the closest x-axis. The closest x-axis is this positive x-axis, but it's not the value of 0, it's the value of 360, okay? So our reference angle is the distance between 360 and 300. So what I do is I take 360, subtract 300. My acute angle must be 60. So my reference angle is 60 degrees. And that's usually written as alpha in your book, the angle alpha, okay? So, if you notice, my reference angle wasn't the distance between terminal side and the y-axis. It's the terminal side and the x-axis, okay? The other thing we need to quickly review is the 4 quadrants and the signs they give to our trig function values, okay? Because the sign's not going to stay at the same time. Just like in certain parts of the coordinate axes, x values are negative, right? Or y values are negative. That also applies to sine and cosine. So, since the angle can put us in any of the 4 quadrants, we need to refer to the chart that I drew for you guys on page 3 of your notes, okay, for signs of function values in certain quadrants. I shortened it here, but I wrote out every single trig function value in your notes, okay? So the way I have memorized this at this point is ASTC, or CATS, or all students take calculus. So what this says is that in quadrant 1, all of my trig function values are positive. So that means cosine, sine, cosecant, secant, tangent, and cotangent are all positive in quadrant 1. In quadrant 2, sine and therefore cosecant are positive. Okay. In quadrant 3, tangent and thus cotangent are positive. And in quadrant 4, cosine and thus secant are positive. Okay? So then whatever's not listed here must then be negative. So in quadrant 2, cosine and tangent are negative. In quadrant 3, sine and cosine are negative. In quadrant 4, sine and tangent are negative. What's nice is that cosine corresponds to x. Okay, so wherever x would normally be negative, that's where cosine is negative. Whereas for sine, it corresponds to y. So wherever y is negative, that's where sine is negative. Okay? So let's look at some examples. In 14, they drew theta for us, okay? It led to the, it leads to the terminal side in quadrant 4, and the point value is 3, -4. So since since the x value, right, is 3, that means our adjacent side to our acute angle is 3, and the opposite side is -4, okay? I've drawn alpha for us. Alpha is the small angle in between. So the triangle we're using is the triangle that corresponds to alpha because that is an acute angle and those are easier to use when we're finding trig function values. Okay? So again, the one thing we're missing here is our radius. So our hypotenuse. So we're going to do Pythagorean. So we got 3 squared plus -4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. R equals 5. Okay, and so now that we have all sides of our triangle, we can find our trig function values. So sine theta, this is opposite over hypotenuse, so that's -4 over 5. Cosine theta is adjacent over hypotenuse, so that's 3/5. Tangent theta is opposite over adjacent, so that's -4/3. Cosecant theta is the reciprocal of sine theta, so this is -5/4. Secant theta is the reciprocal of cosine theta, so that's 5/3. And cotangent theta is the reciprocal of tangent theta, so this is negative 3/4. And there are our 6 trig function values. Now let's look at 18. In 18, the angle theta they gave us is 360 degrees. Okay, so we go all the way around and end on an axis. This angle is called a quadrantal angle. Basically, that just means it ends on a coordinate axis. Okay, so in this case, it ends on the x-axis. These do have trig function values. If you notice, the point value here is 1, 0. However, there is no triangle to go with this. Okay, so you assign cosine theta to the x value and sine theta to the y value. So going off of that, sine theta is 0, cosine theta is 1. And then recall when I wrote down the definitions for tangent, I said tangent is equal to sine theta over cosine theta. So since sine theta is 0 and cosine theta is 1, tangent is 0. Okay. Cosecant theta is the reciprocal of sine, so that's 1 over 0, which is undefined. Secant theta is the reciprocal of cosine, so that's 1 over 1, which is 1. And tangent theta is equal to, cotangent theta is equal to 1 over tangent theta. So this is 1 over 0, so this is also undefined. Okay, and there are our 6 trig function values. So if you end up on one of the axes, you should get answers 0, 1, and undefined as your possibilities. You should not be getting, square root 3 over 2 or something like that, okay? If you're on one of the axes, you should be looking at 0s and 1s and undefineds. Last thing we're going to look at are examples similar to 21 through 28 on your classwork, okay? So what we're doing here is we are naming the quadrant given some characteristics of the trig function values, namely what sign do they have. So this is where the chart on page 3 of the notes is going to come in real handy, okay? So let's look at the first one. It says cosine theta is less than 0 and sine theta is greater than 0. So we know that sine is positive here, cosine is positive here, all of them are positive here, and tangent is positive in quadrant 3. So where is sine greater than 0 but cosine less than 0? Well, if sine is positive in quadrant 2 here, but nothing else is, that means cosine has to be negative here. So quadrant 2 is the answer to the first one. The second one says secant theta is greater than 0 and cotangent theta is less than 0. So what this has told me, remember secant is the reciprocal of cosine. So if secant is positive, so is cosine. So this tells me that cosine theta is greater than 0. And then it says here that cotangent is less than 0. So when cotangent is negative, tangent is negative. So we've got tangent less than 0. So tangent is less than 0, but cosine is positive. That's got to be quadrant 4. The next one says cosecant theta is greater than 0 and tangent theta is greater than 0. Cosecant theta is the reciprocal of sine. So if cosecant is positive, sine is positive, and tangent is positive as well in the same spot. So sine and tangent have to be positive together. So then that means we're looking at more than one trig function being positive. So we're looking at quadrant 1. For the next one, we have cosine theta is greater than 0 and sine theta is greater than 0. That must also be in quadrant 1, right? Because we've got 2 trig function values that are positive here, okay? The next one, we're given that sine theta is negative, and then our theta has to be between 90 and 270. Remember that 90 is the positive x-axis and 270 is the negative x-axis. So we're in between 90 and 270, so we're bounded right here in this area between quadrant 2 and quadrant 3. So between quadrant 2 and quadrant 3, sine is negative in quadrant 3. So my answer is 3. And then for the last one, cotangent theta is less than 0, and theta is still bounded between 90 and 270. So again, we're still looking in quadrant 2 or quadrant 3. Where is cotangent theta negative? Well, that's where tangent theta is negative, right? So that means that it can't be quadrant 3, because in quadrant 3, tangent's positive. So this must be quadrant 2. And there you go. So the classwork due Monday at the end of class, you have 45 minutes, okay, is page 559, numbers 1 through 7, all on the written exercises, and page 565, numbers 13 through 19 odd, and 21 through 28, all on the oral exercises.